believe that everyone has been enlightened a lot. In fact, Buffalo Machinery is already the largest brand of high connection 5-axis machine in Asia, and its products have been sold to many countries, including Germany, Russia, and the United States, etc. Next, I would like to continue sharing something with you. We all know that plastic is an energy-intensive material to produce. So, how can we reduce carbon emissions? At present, in order to alleviate the problem of global warming, the international carbon price has been doubled compared with the price before the epidemic, which will significantly affect the international competitiveness of enterprise. So, next, we will invite Dr. Lin Zhengyan, the director of Precautions, who is also a lecturer of the Plastic Industry Development Center, to share something with us. Please give him a round of applause and welcome.
Hi everyone online. I am Lin Zhengyan from Precautions. I will give you a presentation on energy saving management of injection molding from the viewpoint of carbon neutrality. And on this slide, you will see my CV for your reference. If you have any questions or comments after my presentation, feel free to add me on WeChat or other social media for more exchanges. So let's have a look at the factory of injection molding. What are the types of energy consumption? As we understand, all types of plastic processing are energy intensive, and energy saving is the most direct way to reduce carbon footprint. So in these factories, the energy consumption comes from two sources. The first is loss of heat source, and the second is energy loss during the molding process. So among all the losses that include melting of the dry material of the plastic and cooling of the mold. So in the molding process, after the melt is dried and is injected into the mold, in that process, you need to power the device, and also the energy use in the molding process. And also in the injection process, there is flow resistance, etc. So that is the common energy losses in the injection molding. So first of all, let's take a look at the distribution of the energy use in plastic processing. From this chart, we can see energy consumption is plastic processing, which is 66%. In addition, the chiller accounts for about 11%, and air compression is about 10%. So these are the major energy consumption in the processing of plastic. So what are the types of heat source in the plasticizing process? So in the process of injection molding, we need to melt the pellets so that the injection machine can inject the melted material into the mold. And in that process, the supply of heat comes from two parts. The first is the part of the electric heating source of the barrel, and the second is the mechanical heat of the shearing action of the plastic pellets under the action of the screw. And that has to do with the temperature of the barrel and the heating time. And shearing has to do with the speed of the screw and the back pressure that we set. And they produce corresponding heat sources. Currently, in the plasticizing process, there are technology available for energy saving, and that is the infrared barrel. The energy-saving technology of infrared barrel is combined with far infrared lamps, heat reflection layer, nano insulation layer, stainless steel shells, and high-temperature heat-proof radiation layer. So through the infrared insulation layer, the heat source is prevented from dissipating, and the overall energy saving effect can reach 30 to 55%. At present, the application of such technology is mainly injection molding machine, wire drawing machine, film blowing machine, and extruder. So this technology is available. There is another system that is concerned with the heating of the barrel. That is the induction heating of the barrel. So using this principle of high frequency, we can heat the material tube to promote melting of the plastic. At present, the overall energy saving effect is about 15%. So, however, the cost is higher, so it's not a very popular solution. At present, the heating method of the barrel are these two technologies, and there are solution providers that provide such technology for the use in the injection factory. So other than these two technologies, we often use thermal insulation cotton for insulation. So both the infrared and the thermal insulation cotton, they have thermal insulation layers to prevent heat loss. The thermal insulation layer can save energy but can damage the melting temperature control, resulting in the cracking of plastics. So there are a few things for your consideration. So first of all, there should be enough space for cooling between heaters so that there is not enough space for cooling. So although it will cause some energy loss, but it allows the solution to have better temperature control. Second is to reduce the screw speed so that the screw feeding time is only 1 to 2 seconds shorter than the set cooling time, because if the screw is too fast, it may lead to overheating of the material, and the overheating can produce a poor quality of products, and such melt can lead to defective molded products, and which will increase energy consumption. We should avoid using generic screws or use high compression ratio screws or adding cooling fans between heaters, because these represent poor screw design. Such use may increase unnecessary energy consumption and could also cause risks to the quality of our products. Number 4, increase the temperature of the area and the front area. Reduce the friction of the plastic to the inner wall of the barrel and improve the temperature control. Increase of temperature can reduce occurrence of shear heat. Shear heat is explosive, which is not easy to control. Therefore, slightly increasing the temperature setting of the material pipe in each area will help to improve the frictional shear temperature rise. And the 5th part is to monitor the on and off frequency of heating element temperature control in the process. So through the observation, as long as the frequency of the switch control by the heating element, no matter it's fast or slow, as long as it's being controlled, it means that the entire material tube has temperature control when heating the plastic. For example, if the temperature of the tube is too high, the heater should be switched off. If the temperature of the tube or melt is too low, the heater should be on. So when it's on and it's off, that means that the temperature is being controlled. After all, the formation of good quality products and efficient operation is the true effect of energy saving. We must take into account the overall production efficiency. If we use energy saving tubes, but if the quality of injection is not good or the yield is not high, the energy consumption will be even greater. And next, we'll compare energy saving of power-driven injection machine. At present, the power drives used by the injection machines are variable frequency energy saving device, variable pump energy saving oil electric hybrid system, and full servo hydraulic pump motor system. What are the differences? In early days domestic machines, the hydraulic machines, we use frequency conversion technology for modification for energy saving. And with later development, a motor was developed and mass produced, gradually replacing some of the hydraulic devices. So we have a hybrid system for oil and electricity, as well as the currently used servo motor system or a full servo motor drive system. And there's evolution of the technology that also helps to save energy. First of all, we focus on the system architecture of servo energy saving. The traditional servo energy saving system, such as the picture on the left, is an open loop state. In the later stage, it is a closed loop system on the right side. The main difference between the closed loop system and the open loop system is that we install a pressure sensor at the outlet of oil pump. We use the pressure sensor to feedback the servo driver of the signal according to pressure changes in the process. And then we offer correction and compensation through such pressure feedback so as to achieve output power source of a high precision. In the testing process, we use the fixed speed motor, what we call the standard pump, and also the pump is different sizes used to test the flow and pressure, and also the variable pump, and also the servo oil pump for comparison. So in the comparison of all these different pumps, the servo oil pump system can achieve an energy saving effect of 33.1%. Compared with the standard pump, which is a power saving circuit with the connection of multiple fixed speed motors, combining large and small oil pumps and variable pumps, our system can achieve very significant effect. And this is also the major trend in the current injection machine using the servo oil pump. In the results of our past tests, we compared the same modes and raw materials with different Japanese-made systems and domestic systems. In fact, at present, the maturity of the technology can reach an international level and also achieve a relatively good energy-saving benefit. In addition to the energy-saving effect of using servo oil pump, in order to achieve stable control of the machine, we also observed the response of pressure and speed following commands under the changing conditions of the molding process. In the picture on the right-hand side of this chart, we can see the output of the pressure and output of the velocity achieve very fast response and follow-up of a command. Therefore, in the current servo energy saving system, it has a very significant advantage in terms of energy saving and motion control. The servo oil pump uses a servo motor. So can it cope with the kind of molding condition that requires high load and constant pressure. Currently, the oil pump that we use is very effective. So compare the development of our system with the same Japanese product. The load capacity is 180% higher, and it is suitable for forming thick parts with high torque and high load, such as PM and APC. So the maximum load time can be as long as 60 seconds without tripping, and the pressure stability error is less than 1%. It also has excellent pressure resistance. And this is a device that we have tested for your reference. For the injection molding machine, motor-driven oil pump has been the major consideration for energy saving effect. So we will install servo driver for better matching the motor load and demand. And the new motor has a higher energy efficiency, and we consider to replace the old motor on the equipment with more energy efficient model and turn off motors that are not contributing to production, and regularly monitor and maintain motor, and upgrade and reform old equipment control platforms with newer technologies, including more energy efficient components and improved control algorithms. And new control panels they often use touch panels that are graphical and easy to follow and understand. Next, I will talk about vacuum feeding system. The benefits of vacuum dehumidification feeding system. The vacuum dehumidification feeding system uses timed and fixed amount feeding, which is different from traditional feeding method. By reducing the amount of feed, it can maintain space between the feed, which helps to separate water vapor. So let's take a look at the benefits of vacuum dehumidification feed system, which reduces the back pressure required for molding, eliminate contamination, less clouding, reduce air bubbles, eliminate sulfur streaks, and improve texture, reduce mold deposits, shorten material preheat time, and achieve overall personnel saving. The principle of decompression and dehumidification is to use the vacuum negative pressure in the barrel to reduce the temperature of water evaporation, so as to achieve the effect of rapid evaporation and removal of water vapor. So this is the principle of the vacuum feeder, with timed and fixed amount feeding achieved through the rotation speed of the upper feeding screw. When the pellets enter the plasticizing screw, the space between pellets is maintained so that air or moisture can be easily pumped out. In the design of the barrel, we use sealed components and process assembly on the metal surface of the barrel. And during the molding process, the sealing of the entire barrel is formed. The vacuum feeding system is pumped to form a vacuum negative pressure in the interior of the barrel to achieve decompression and dehumidification. Here's an exploded view of the vacuum barrel. So during feeding, when the plastic is heated at high temperature, the water vapor, waste gas generated are extracted at high speed using high vacuum negative pressure. Surface fogging and brightness is improved, and product yield is improved. With that system, we can shorten the time and lower the temperature of plastic preheating and drying to achieve energy saving. And after removing the gas in the feeding barrel, the feedback pressure is greatly reduced to save energy. And reducing the feedback pressure can reduce the overflow and prevent brittleness. For surface appearance optimization, because of the effective feeding, the plastic slowly falls into the feeding port, and the residual stress of the plastic after injection molding is small, which helps to eliminate the shrinkage of bonding line and the finished product. And to lower the molding temperature, the time and fixed amount feeding can effectively reduce the shear heat energy of the screw and reduce the feeding barrel temperature and cooling time, and then reduce the molding temperature. And it also reduces baking time. You can choose to go with various drying system or without, and it can effectively shorten the time, and it can save a lot of energy. According to our experience, most of the quality requirements can be achieved by vacuum dry materials. Unless there are special requirements and a high degree of drying is needed, then we'll need additional drying system. And that can effectively shorten the entire drying time and saves time and energy. In addition, in the process of vacuuming, the dust between the pellets is also absorbed. So when the dust enters the feeder, it may cause cracking and black spots due to excessive temperature. And the system also helps to get rid of exhaust of the material barrel. So that is the information for the entire vacuum feeder. Here's an example to share with you. This is a car lamp from a particular brand. And under normal lighting, you don't see the white fox on the lamp. But under strong light, you will see some watermarks, like the photo on the right. It is actually a white stripe. If you look closely, there are many small air bubbles, which creates a streak or the watermark. And after we use the vacuum feeding system, you don't see the streaks anymore. And this is the leg of an office chair. From the picture above, the photo is a chair leg using the vacuum feeding system, and the below picture uses a general drying system. And we can see the excellent performance from two places. Well, the first one in the picture above has a relatively high brightness, and compared to the picture below, it shows white fog, and the effect is much better. And then the transcription of the surface texture, the picture shows the transcription of the texture on the surface of the product, and the picture below, you do not see that. And this is a PC product. Picture on the left uses a general drying system, and the one on the right uses a vacuum drying system. You can see the difference. The one on the left does not use a drying system, and the one on the right that only uses the vacuum feeding system. So in this case, the picture on the right has reached the appearance quality requirement for the product. And this is a pencil case, pencil holder. So in such a state, the picture on the right does not use a general traditional drying system. It greatly saves heat loss during the drying process. And next, I will introduce the application of molding technology in energy saving efficiency. I will tell you about MuCell microfoaming. The microfoaming process is widely used in auto parts, and interior parts. And in the future, it may be applied to various molding needs in the future. It has very good energy saving effect. I will explain to you. First of all, let's understand the microfoaming technology. It injects nitrogen or carbon oxide from the top of a barrel during the molding process. And using the geometry of the screw, it can mix the air and material to create a homogeneous melt. Because the material barrel is in a closed state, when we need to inject material into it, we open the nozzle and quickly shoot the material into the mold. And in that process, there is a change in the air pressure and bubbles are released. It's just like when you drink soda. When you open a bottle of soda, a large amount of carbon dioxide is released from the carbonated water. MuCell foaming uses the same concept, so which is similar to carbonated water. Nitrogen or carbon dioxide is like the gas in the soda. And in the filling process, the melt flows while carrying out the bubbles. And since the melt enters the mold cavity, it will first touch the cool wall surface to form a top layer. And in the core of the product, because the temperature is very high and also maintained at very high, there's a chance for the bubble to be separated in the filling process and stay in the thick layer. So that is the main equipment and technology of the process. It uses traditional injection molding machine with upright nozzle, dedicated barrel, and components of pumping interface and a pressure sensor in the barrel and a gas control system. And these are all integrated into a system. The technology of microfoaming, it can use different short injection and the intake of nitrogen or carbon dioxide to control the size of foam and to achieve a stable molding state. And here's an introduction to supercritical fluids. Supercritical fluid is a homogeneous mixture of gas and liquid formed in the melt at a specific temperature and specific critical pressure. It is easy to diffuse, easy to mix, and has low compressibility, very precise metering, and can be used for the process of injection molding. A technical feature of the process is that it can help to reduce the weight of our products, reduce the molding cycle, reduce the required clamping force, and the dimensional accuracy of the product. We can see that the thick layer will form in the molding process, and it will help to reduce the weight and also the use of material or material loss, and it is great for our environment. Next, the foaming process shortens the molding cycle. In the traditional method, we need to go through injection, molding, and pressure holding and cooling, and using pressure holding to compensate for the shrinkage during the cooling process. By microfoaming, the gas is released from the melt, which replaces the pressure holding. So basically, compared with traditional method, it doesn't require pressure holding. And the foaming process is also a thermal reaction, which also shortens the cooling time. And microfoaming is a liquid state, and the fluidity is very high, so it does not need to be in a high temperature, and it can already achieve very good fluidity. Therefore, in general, in the microfoaming molding process, the barrel can be set at a lower temperature. And of course, the lower temperature helps to reduce the cooling time and also helps to save energy of the heater. Here we can see traditional process and the MuCell process. The overall viscosity is greatly reduced. The demand pressure for molding is also greatly reduced in the molding process, as shown in the green curve. And we can see in the traditional process, the pressure peaks reach a maximum of 1045 bar. But for MuCell, for the same object, the pressure peak is just about 448 bar. So the molding pressure is greatly reduced by about 50%. So in terms of temperature or flow resistant, MuCell saves much energy. Since the film is released from the inner thick layer, it does not need much pressure holding for pressure compensation, and it can achieve very good dimensional accuracy and also reduce shrinkage of the product. In order to prevent curving of the product, in the past traditional molding, there were many different methods, including setting of high holding pressure, long holding time. It's a waste of time and energy, and also the methods were not very effective. But MuCell, the technology, can solve this problem. Next, we will consider the strategies for reducing energy consumption from the viewpoint of molding process. So first of all, if the melting of the plastic material comes from two heat sources, first is the electric heater, and the second is the mechanical energy, what is we call the process condition. Say, for example, the screw rotation speed, the back pressure, and setting of corresponding injection speed and pressure, and they can all make the plastic generate enough heat to melt. A key variable for uniform melting and cooling of plastics. Well, there are hundreds of variables in the 24/7 injection molding process, and it's difficult to decide which one is correct. But considering the top 10 variable uniformity of plastic melting, which refers not only to the melting temperature, but also the viscosity of the melt, means there's no swirls, streaks, or undissolved particles. A melt homogeneity between amorphous and semi-crystalline product must be achieved within 24/7 uniform size and performance requirements. And the temperature includes overall and mold temperature. So the temperature not only has an effect on viscosity, it would also affect the final molecular weight of the plastic in the molded parts. So although increasing the melt temperature can adjust the melt viscosity to obtain better flow characteristics, and it is usually accompanied by viscosity variation and physical property attenuation during the production. With sufficient injection pressure setting, increasing the injection speed can obtain lower melt viscosity, faster response, and lower flow resistance. Therefore, in order to reduce the process temperature, if we increase the process temperature by 1 degree Fahrenheit, it will save approximately 1.5% of the chiller energy consumption. So considering the maintenance of melt physical properties, mass production viscosity stability, and energy consumption, the set value of melt temperature should be low. And although the mold temperature effect on viscosity is not as great as melting temperature, it still have a greater effect on final properties. Amorphous materials such as ABS and PC will cause lower levels of forming stress and have better impact resistance, stress crack resistance, and fatigue resistance. Semi-crystalline materials such as PBT and nylon, mold temperature is an important factor. Determine the crystallinity of the material. Crystallinity controls many properties, include creep resistance, fatigue resistance, wear resistance, and dimensional stability and stiffness at high temperature. So high mold temperature usually leads to good cycle and good physical properties, regardless of what material is used. Crystal can only be formed at temperatures below the melting point, but above the glass transition temperature of the plastic. Therefore, if the temperature of the mold is good and high, it is easy for the semi-crystalline material to have a better transformation in the formation of the lattice. And here we can see an example. With PPA 35GF, the TG is 145 degree. For this material, we can see in the chart, the horizontal axis is the setting of ambient temperature in the post-molding test. The vertical axis is elastic modulus. There are 4 samples formed by different mold temperatures, namely the mold temperature at 57 degree, 90 degree, 125 degree, and 159 degree. The 4 samples were set with different ambient temperature to understand the changes between the elastic modulus. We can see at room temperature 25 degree, the mold temperature of 159 degrees has a higher elastic modulus and also higher strength. Then the 4 samples, they are placed around 145 degree, and we can see the elastic modulus dropped significantly. However, at 57, 90, 125 degree, the elastic modulus slightly increases respectively when they exceed 170 degree. However, the sample formed at a temperature of 159 degree does not have that phenomenon. Then why is that? Why is that the ones formed at 57, 90, and 120 degrees, why do their elastic modulus change when it exceeds 170 degrees? That's because in the process, there is out of mold crystallization, and because the material is recrystallized and regrown, it will affect the overall rigidity improvement and change in dimensional shrinkage. Just now we saw semi-crystalline material, and let's take a look at the non-crystalline material such as ABS and PC, whether it still have good physical property maintenance under high mold temperature. We can see in the graph on the lower right corner the interaction of ABS impact performance at a set value between mold temperature and overall temperature. And here we can see that the mold temperature has an influence on the impact resistance, which is the dominant factor. The graph has 2 directions on the horizontal axis, that's mold temperature and melt temperature. The vertical axis is impact strength. The melt temperature of 274 degrees corresponds to the mold temperature of 29 to 85 degrees respectively, and a huge improvement in the overall impact resistance is observed. However, if the mold temperature is at 29, the melt temperature was changed from 218 degrees to 274 degrees. The impact resistance improved very little. So we can see the influence of mold temperature on the impact resistance is much greater. If we put together the mold temperature and overall temperature, when mold temperature is at 85 degrees and melt temperature at 218 degrees, the product has best impact resistance which corresponds to high mold temperature and low overall temperature. So the low melt temperature and the high mold temperature can save energy by reducing heat source for the melt. And compared to the heat removed in the cooling process, such a method can greatly save energy consumption in the molding process. And at the same time, it maintains the physical properties, whether it's semi-crystalline or amorphous materials. So set the correct molding temperature and melt temperature can be very beneficial for energy saving and physical property maintenance. So in a conclusion, lower melt temperature combines with higher mold temperature can produce optimum mechanical properties. And the combination of lowering the melt temperature and increasing mold temperature does not necessarily increase the cooling time required to produce dimensionally stable parts. So the setting of mold conditions on the production site are often quite the opposite, though. Traditionally, they often use relatively high melt temperature and low mold temperature. Although high melt temperature brings good molding fluidity, low mold temperature shortens cycle time, but often damages the physical property of plastical parts and increases energy consumption. So for that, we can improve the process to reduce energy loss and improve overall efficiency. And that is my presentation on this topic.